video will cover example 2 from section 8.1, which is Gaussian Elimination and Gauss Jordan, actually major solutions to linear systems. First, we are creating our augmented matrix, so we need to make sure the equations are written in order, x, y, z. The coefficients of the first row were 3, 1, and 2. Second row, they are 1, 1, and 2. Third row, they're 1, 3, and 2. And on the right side of the line, they are the constant terms, 31, 19, and 25. Now, remember that our goal is to obtain something like this. Ones on the main diagonal and zeros below the ones, right? Yes? So what we're going to do is, since we already have a 1 here, we'll propose that we interchange R1 with R2. You could also choose to interchange R1 with R3. That's fine. It doesn't matter. So since we're just interchanging them, the second row will become the first row. And the second row will be what used to be the first row, including the number after the line, including the constant terms. From here, we will have 1, 3, 2, and 25. So we didn't do anything to the third row. Okay, now we do have that leading row. Okay, so now that we have a 1 here, we're going to say that R1 is our leading row. What that means is that we're going to use R1 to make the zeros below it. Don't make that face. All right. Now, what we need to do is make this number 3 a 0. So the operation we're going to use is going to be R1 times the additive inverse of 3. So what is the number that you need to add to 3 to get a 0? Negative 3, very good. So R1 times negative 3 plus R2. And that is going to replace the second row. So before we do anything, let's just copy the first and the third rows. So 1, 1, 2, 19. 1, 3, 2, 25. So below here, I'm going to do my scratch work. So R1 times negative 3. R1 is 1, 1, 2, 19. So we multiply that by negative 3, and we will get negative 3, negative 3, negative 6, and negative 57. You know this looks like a 12, but it's just 1, 1, 2, 19, okay? So I just distributed the negative 3. From there, we need to add R2. So, Sean, read R2 for me, please, from the previous step.
3, 1, 2, 3.
Okay, now we're going to combine the two rows. So negative 3 plus 3 is 0. Negative 3 plus 1 is negative 2. Negative 6 plus 2 is negative 4. Negative 57 plus 31, it is 26. Negative 26. So now that one will be the new R2. 0, negative 2, negative 4, negative 26. Now we are done with that 0. So now what we need to do next is turn this one into a 0. So we're going to make 1 and R2 a 0. So we're going to use the same reasoning that we used here. We still need to use the leading row, which is R1, and the additive inverse of 1. So that will be R1 times, what is the additive inverse of positive 1, Lorenzo? What number do you need to add to 1 to give you a 0? Negative 1. That is the additive inverse. And so we add that to R3 to make a new R3. We're going to copy R1 and R2 the same because nothing's going to change. And so now we're going to multiply R1 times negative 1. So that will be negative 1 times R1, 1, 1, 2, 19. So that will just change to the opposite sign. So that's negative 1, negative 1, negative 2, negative 19. To that, we need to add R3. So, Gabriel, could you please read R3 for me from the previous step?
1, 3, 2, 3.
Okay, so now we're going to add these two rows, and what we get is negative 1 plus 1 is 0, negative 1 plus 3 is 2, negative 2 plus 2 is 0, negative 19 plus 25, it is 6. So now that will be the new R3. 0, 2, 0, and 6. So now what is next, guys? We're done with the first column. Now we move to the second column. What do we need to do first? Okay, so very good, Sean. So turn this negative 2 into a 1. So to do that, I am going to use the multiplicative inverse of negative 2. So we need to turn negative 2 in R2 into a 1. So when I say the multiplicative inverse, it's a number that when you multiply it by, you get 1. What is that number? Negative 1/2. So it will be the reciprocal of 2, 1/2, right? And then Lima is telling me negative because somehow we need to end up with a positive 1. So that's why we need negative 1/2. So then we will say R2 times negative 1/2. So, Chris, tell me what was R2, please.
R2 is 0, negative 2, negative 6. Zero, 0, negative 2, negative 4, negative 6.
Before multiplying? Negative 2, what else?
Negative 4.
Uh-huh.
Negative 26.
Okay. So when we multiply by negative 1/2, make sure you account for the negative signs, okay? So negative 1/2 times 0 is still 0. Negative 1/2 times negative 2 is positive 1. Now negative 1/2 times negative 4, that will be positive 2. Remember that multiplying by 1/2 is the same as dividing by 2. Yes?
So we're doing the multiplicative inverse of R2 then to get negative 2 to 0?
Yes, so the multiplicative inverse of this number. So anytime you want to make ones, you use the multiplicative inverse. Anytime you want to make zeros, you use the additive inverse. All right, and then finally, negative 1/2 times negative 26 is positive 13. So now that is my new R2. Okay, we're just going to copy R1 and R3 like they were from the beginning. So, Andrea, tell me what was R1 from the previous step.
R1 was 1, 1, 2, 19.
Okay, and Biryani, what was R3?
0, 2, 0, 6.
Thank you. Okay, we're almost done, guys. So now, what we need to do, we're done with that ones here and here. Now we need to make this 2 turn into a 0, right? So we're going to make 2 in R3 a 0. Additive inverse, yes. So we're going to use, now the leading row is R2 because we're using this 1 to make that 2 turn into a 0. So we're going to say R2 times the additive inverse of 2, which is negative 2, plus R3, because that's the row we're trying to change. Let's just copy R1 and R2. And so now R2 times negative 2, so it's going to look like this. Raquel, tell me R2, please.
0, 1, 2.
Okay, so now we multiply negative 2 times every element in that row. That will be negative 2 times 0 is 0, negative 2 times 1 is negative 2, negative 2 times 2 is negative 4, negative 2 times 13 is negative 26. To that, we're still going to add R3. And R3, Samantha, would you please read that? R3 from the previous step.
0, 2, 0, 6.
So 0 plus 0 is 0. Negative 2 plus 2 is 0. Negative 4 plus 0 is negative 4. Negative 26 plus 6 is negative 20. And so that one will be our new R3. 0, 0, negative 4, and negative 20. If you need to go to the next page for space, that's fine. I'm going to stay on this one. Now, so from here, we're almost done with it, right? Except that we don't have that last one in the main diagonal. What do we have instead?
Negative 4.
A negative 4. And so we wish that was a 1. But that is very simple. All we need to do is multiply negative, that row actually, the whole row, by its multiplicative inverse. So we have to turn negative 4 into a 1.
Wouldn't it be 1 divided by 4? Negative
1 divided by 4, and we need to make it negative, so that we have negative times negative positive. Okay, so Michelle, I want you to tell me what was R1.
1, 1, 2, 18.
Okay. Jonathan, R2.
0, 1, 2, 13.
Okay. And Miguel, so we're going to multiply negative 1/4 times R3. Tell me what was the old R3?
0, 0, negative 4.
Okay, so we distribute that negative 1/4 times 0 is still 0, times 0 is still 0, and negative 1/4 times negative 4 is 1. Negative 1/4 times negative 20, remember it's dividing by 4, so 20 divided by 4 is 5. And I say positive because we have negative times negative. So that will be, our new R3 will be 0, 0, 1, 5. And we're done doing that.
So the other one we're gonna learn about Gaussian Jordan is gonna be longer because we're gonna have to do the other three.
Correct. We're gonna make this one a 0, this a 0, and this a 0. Yes. Okay, now let's go to back substitution.
Wait,
Yeah.
how come in, like, monotone, you use different rows and then, the row?
Teachers and students, please pardon the interruption. Please to the Northwest broadcast in 15 minutes. Thank you.
Wait.
Okay. So that is because we have to use the leading row. So when we started, we were working on the first column, right? We were starting on the first column, so R1 was our leading row. Once we finish with that column, like you could see here, you could see that here, then we made that -2 turn into a 1. And so once we do that, R2 becomes our leading row. So let's write that down here. So now R2 is the leading row.
So we're always using the one on top? Or no?
Well, you move by columns. When you're working on first column, R1 is your leading row. When you're working on the second column, R2 is your leading row. And when you're working on the third column, R3 will be your leading row. Okay? So let's do the back substitution now. And remember how I told you have to make sure that you line up your coefficients correctly so that all of the x's are in the first column, all of the y's are in the second column, and all of the z's are in the third column. So the back substitution, what it means is that 1z is equal to 5. This row, it means 1y plus 2z is equal to 13. And this one means 1x, 1y, 2z is equal to 19. So we create those equations. X plus y plus 2z is equal to 19. And then we have 1y plus 2z is equal to 13. And then, of course, this one is already given to us. It is z is equal to 5. So then the term back substitution, it means that this one, we're going to substitute it with the numerical value 5. So we will have y plus 2 times 5 is equal to 13. So y plus 10 is equal to 13. So y is equal to 13 minus 10. Therefore, y is equal to 3. So now we have two numerical answers. One for z, one for y. And what we need to do next is substitute those. So x, we substitute this y with 3. And we substitute z with a 5. And then we solve that just like a regular linear equation. So x plus 3 plus 10 is equal to 19. X plus 13 is equal to 19. So x is equal to 19 minus 13. X is equal to 6. And so there you get your solution of 6, 3, 5. A point in a three-dimensional space. And that is the intersection point. Now, just to summarize this, let's say when trying to make A1, use the multiplicative inverse. Such as if you have a number, let's call it A, the inverse, multiplicative inverse will be 1 over A. when trying to make a zero, you will use the additive inverse. So for example, a plus negative a, that is an example of the additive inverse. All right. So what we're going to do next is, we're not going to do that one. You are going to do it on your own. Because I know on the homework, you're going to be using your calculator. I know you.
Have you used it?
Yeah.
I taught you guys last year in Algebra 2. I'm sure you could figure it out. Anyways, you're going to do this, and you're going to turn it in next class on a separate piece of paper. You may work in groups if you want to. That's fine.
We can see if it's broken.
Actually, I will make that. No, I can't give you extra credit on a take-home exam. I'll think about it. You have to do it. Anyways, now let's move on to the other method. No crying. I don't want to hear any whining. So the next method, it is Gauss-Jordan elimination. And Gauss-Jordan elimination, stop talking please. So it's named after Brianni, I can hear you. Named after the same guy, Carl Gauss, and no wait, sorry. Wilhelm Jordan. Who lived around his years. And so it continues the process from Gaussian elimination until a matrix with ones down the main diagonal and zeros everywhere else. Such a matrix is said to be in reduced row echelon form. I cannot stress this enough on the take-home exam. If you don't show me all of your steps, you're not going to receive any credit for it. So in other words, what we're trying to get is the identity matrix on the left side. And so the identity matrix is a matrix that when you multiply it by another matrix, you get the same matrix. We're going to talk a little bit more about that on Thursday. So it's like multiplying a number times 1. That is the identity matrix. So once you get identity matrix, the numbers that you will get here, those will be your solutions for, if you have x, y, and z, those will be your solutions for 1z is equal to that, 1y is equal to this, and then 1x is equal to that. So the steps are the same. We're going to move by columns, and the good news is that the system that we're going to finish is the one that we already started working with. So we're just going to continue the process, all right? So if you notice, it is the same system. So Emily, I want you to tell me the last matrix that we had before we did that substitution, please. I think this was a 5, right? Okay, so the first row. Okay. A 2? Okay, so the first column is done for us. So we're going to continue with the process. Now, we're done with the first column, so R2 is our leading row.
Why is that?
Because we are done with the first column, we're moving to the second column, and so we're going to use that one to turn this one into a 0.
Okay, I get you.
I hope you do.
Well, I was thinking of rows.
All right, so what we need to do is make that one in R1 a 0. So again, we're using R2 as our leading row. So we will have R2 times, what is the additive inverse of 1? -1. So R2 times -1 plus R1. Because that's the one we're trying to change.
This way.
Yes.
Is that the columns? Like,
Wait.
Doing
yeah, like,
For the columns. For the first column.
we use the rows, right?
Yes, we use the rows, that's why I'm saying
We use the
R2.
columns.
But what Viviani asked me was why is this our leading row? And I told her because we're working on the second column.
Thank you.
Uh-huh. Okay, so R2 times -1, just quickly, this is R2, right? So it's going to be the opposite signs. So 0, -1, -2, and -13. Now we add R1, so that will be 1, 1, 2, and 19. So if we do that, we will get 1, 0, 0, 19 minus 13 is 6. So that will be our new R1. 1, 0, 0, 6. Yvette, could you please read R2 from the previous step? 0, 1, 2, 3. Okay. And Samantha, did you already read a row for me? Okay. Alexis, read R3 from the previous step.
0, 0.
Okay. And so we were actually lucky that we got another 0 here, right? Without even trying for it. Now, there's just one last thing to do. Which one is our leading row now? R3, right? Because we're going to use this one to make this 2 turn into a 0. So now we're going to make 2 in R2 a 0. And so we're going to use the additive inverse for that. So that's going to be R2. I'm sorry, not R2. What should I use instead of R2? R3, right? Because that has the leading 1. So R3 times the additive inverse of 2, which is what? Additive -2 plus R2. Okay, so I'm going to copy, before I forget, I'm going to copy R1, 1, 0, 0, 6. And I'm going to copy R3 because I'm not doing anything to it. I am actually done with it. Okay, so R3 times -2 is going to be 0, 0, -2, and -10. That's multiplying this row times -2. And then I'm going to add R2. So, Jose, read R2 for me.
0, 1, 2, 13.
Okay. So that will be 0 plus 0 is 0, 0 plus 1 is 1, -2 plus 2 is 0, -10 plus 13 is 3. So 0, 1, 0, 3. And then we are done. And that will give you the answer. So we have that 1x is equal to 5. 1y is equal to 3, and 1x is equal to 6. So x is 6, y is 3, and z is 5, which is the same thing we got from the previous method, right? Yeah, you guys remember? Okay, sometimes, well, I remember the first time I saw this, I thought it was very overwhelming, but then as you practice, you can actually get pretty good at it and pretty fast. And instead of doing the Gaussian elimination where you stop and then you do back substitution, I used to just go like to the Gauss-Jordan. I thought it was easier. But I mean, that's just me. Yes, Miguel?